Good evening, all.
Good evening, ma'am. Good evening, all.
Good evening, ma'am. Good evening, all participants.
Good evening, sir.
Good
Can you
evening,
hear
sir.
me?
Yes, ma'am. Yes, ma'am. I can hear you.
Good evening, sir.
Good evening, sir.
Good evening, ma'am.
Good evening, ma'am.
Good evening, all participants.
Good evening, sir. Good evening.
grace of Almighty, we are eminent to start 6 days online Atal FDP inauguration. Good evening, everyone. With immense pleasure, I welcome you all to the inaugural ceremony of Atal Online FDP on Generative AI in Shaping Industry 6.0, organized by Department of Computer Applications, Congo Arts and Science College, Autonomous, Erode. Today marks a significant occasion as we came together to explore the transformative impact of generative AI in the era of Industry 6.0. It seeks to enhance the competencies of faculty in integrating advanced AI technologies into teaching, research, and innovation. I now invite Dr. T. A. Sangeeta ma'am, coordinator of Atal FDP, Associate Professor and Head, Department of Computer Applications, to deliver the welcome address and warmly welcome our gathering.
Thank you, ma'am. Good evening, one and all. With immense joy and pride, I extend my warmest welcome to each and every one of you to the inaugural function of 6-day online Atal Faculty Development Program on the theme Generative AI in Shaping Industry 6.0, organized by the Department of Computer Applications, Congo Arts and Science College, Autonomous, Erode, Tamil Nadu. To begin with, we humbly extend our gratitude to the Almighty, whose divine blessings have united us virtually for this important academic endeavor. It gives me great pleasure to commence this program with a warm welcome. To begin with, I would like to extend our heartfelt greetings to our Honorable Correspondent Sir Thirupi Sachidanandan Avargal, whose dynamic guidance and unwavering support have always been the driving force behind our endeavors. I also extend my cordial welcome to our respected and esteemed principal, Dr. H. Vasudevan Sir, whose visionary leadership inspires excellence in every aspect of our college. A very special word of welcome goes to our eminent resource persons who will enlighten our over the course of next 6 days. We are indeed fortunate to have with us distinguished academicians, researchers, and industry experts who will be imparting their valuable insights on generative AI and its transformative role in Industry 4.0. It is indeed a great honor to welcome our resource person Abhinaya Kamalakannan has graciously joined us today. Ma'am, your gracious acceptance to be with us despite your busy schedule is a privilege we truly cherish. We eagerly look forward to your inspiring address, which will set the right tone for this faculty development program. I warmly welcome all our participants who have joined us from across the country. Your active encouragement, enthusiasm, and willingness to learn are what make us programs meaningful. I'm confident that your diverse experience and perspectives will greatly enrich the discussions and learning outcomes. Our computer science, our computer application was established in the year 2009 with a sanctioned intake of 60 with BCA program. And the curriculum development of our department makes a continuous revision and upgradation of the curriculum to meet industrial standards to our students. To enhance career opportunities, we conduct placement training programs through our active placement and training cell, preparing students for successful careers in leading MNC companies. The department has also established a software division to support academic and industrial needs, providing software solutions and signing MOUs for various collaborative academic activities. Our students have been successfully placed in reputed companies such as Zogo Corporation, Infosys, TCS, Wipro, CTS, LT Mindtree, Capgemini, and many more. Beyond academics, we are deeply committed to serving society through quality education, innovation, product development, and research, thereby shaping our students into skilled professionals and responsible citizens. Our commitment to academic excellence has earned us national recognition, ranking 71st in India today and 65th in Outlook iCare among the top BCA colleges in India. According to the Generative AI in Shaping 6.0 is both timely and futuristic. As we step into an era of hyper-connectivity and intelligent automation, generative AI stands as a transformative force driving innovation across industries and education alike. This AICT Atal Academy FDP offers us a valuable platform to explore emerging dimensions of generative AI over the next 6 days through sessions and discussions. We aim to strengthen our teaching, research, and ability to guide students towards innovation and excellence. Before I conclude, I once again extend a warm welcome to our correspondent, principal, chief guest, resource persons, participants, and organizers. Let us work together to make this FDP meaningful and impactful. Thank you and best wishes for its success.
Thank you, ma'am. Now it's my privilege to invite our beloved principal, Dr. H. Vasudevan sir, to deliver the felicitation address. We are fortunate to have your constant support and guidance, and we look forward to your words of encouragement and blessings on these occasions.
Thank you, madam. Good evening to everyone. I am happy to welcome you all to the 6-day AICTE-sponsored online faculty development program on Generative AI in Shaping Industry 6.0. Warmly greet the resource persons, faculty members, and participants who have joined us for this evening session. Generative AI is changing industries in many ways. As we move towards Industry 6.0, it is important for educators to learn these new skills and prepare the next generation. I sincerely thank the Department of Computer Applications for organizing this 6-day faculty development program, particularly Dr. T.A. Sangeeta, Mr. Iswaramurthy, and the entire organizing team for their dedicated efforts. I also thank AICTE for sponsoring this program and supporting such valuable initiatives. I'm confident the sessions over these 6 days will give useful knowledge, inspire new ideas, and encourage collaboration among faculty members. I wish this faculty development program great success and all participants a truly enriching learning experience. Thank you, Ananda.
Thank you, sir. It's with great pleasure. Now I'm inviting Ms. Abhinaya Kamalakannan, IT Analyst, Tata Consultancy Services, Coimbatore, to present the inaugural address.
Good evening. Am I audible?
Yes, ma'am.
Yes, ma'am.
Thank you. Respected correspondent Tirupi Sachidanandan sir, esteemed principal Dr. H. Vasudevan sir, head of department computer application Dr. T.A. Sangeeta ma'am, my dear faculty members and distinguished participants, a very good evening to one and all. It is with great honor and immense pleasure that I stand before you today to inaugurate the Atal Faculty Development Program on Generating AI in Shaping Industry 6.0. This program is not just another event in our calendar, it is a testament to our collective commitment to lifelong learning and academic excellence. In an era defined by rapid technological advancements and evolving knowledge paradigms, the role of an educator extends far beyond the traditional classrooms. You are not merely the dispensers of information, but facilitators of discovery, mentors who inspire, and lifelong learners. The Atal Academic Faculty Development Program, a visionary initiative by the All India Council for Technical Education, is designed to empower us, the educators, with the cutting-edge knowledge and skills required to navigate the dynamic landscape. It is a powerful tool to bridge the gap between the theoretical knowledge and practical applications, ensuring that our young minds are not just prepared for present but are equipped for the future. Congo Arts and Science College, Erode, stands as a beacon of academic excellence and holistic development since 1994. The autonomous institution is approved by AICTE, affiliated to Bardar University, accredited with A+ grade and recognized by UGC. The Department of Computer Applications is ranked as #1 in Erode district by India Today MDRA ranking. So they have many students have placed in the MNCs, and the college also recently launched a program on AI and ML. They have started an initiative program on ATAL development. The FDP focuses on the depth exploration of generative AI in shaping the industry 6.0. So over the next few days, we delve into the transformative world of Gen AI. So thank you for the wonderful opportunity. Wishing everyone involved a successful and impactful FDP program launch. Let us make this a truly enriching and collaborative learning and experience. Thank you.
Thank you, ma'am. Every good beginning must come to a fitting close. To conclude today's inaugural session, I now invite Mr. G. Ishwarmurthy sir, Assistant Professor, Department of Computer Applications, to propose the vote of thanks.
Happy evening to one and all. It's indeed an honor and privilege to me to deliver a vote of thanks in this special occasion on the inauguration of our 6-day online faculty development program on generative AI in shaping industry 6.0. Sponsored by AICT Training and Learning ATAL Academy, organized by Department of Computer Applications, Congo Arts and Science College, Erode, Tamil Nadu. It is our heartfelt thanks to AICT ATAL Academy on behalf of the entire organizing team and participants for accepting our proposal to conduct this 6 days faculty development program on generative AI in shaping industry 6.0 through online mode. It is my honor to extend a special note of gratitude to our respected correspondent sir, Thiru P. Sachidanandam Avargal, for gracing today's inaugural function of the 6 days FTP. On behalf of the entire organizing team and participants, I sincerely thank you, sir, for your time and blessings. Thank you, sir. Very special thanks to our respected principal, Dr. H. Vasudevan, sir, for your continued support, encouragement, and guidelines. Your vision for academic excellence and your commitment to staying ahead of technological advancements are what made this FTP is possible. Thank you very much, sir. Yeah, very special gratitude to our chief guest, Ms. Abhinaya Kamalakanan, of this inaugural session of 6 days faculty development program on generative AI in shaping industry 6.0. Your words during today's inaugural session were not only inspiring but also remind us of the importance of staying updated and adaptive in the rapid evolving world of technology and education. Thank you, ma'am, for motivating us to explore and embrace technologies like generative AI. Thank you, ma'am. I take this moment to extend a heartfelt thanks to all our eminent speakers who are truly thankful for your willingness to share your knowledge and insights during these sessions ahead. We eagerly look forward to learning from your expertise throughout this program. Thank you all. I extend a special thanks to our beloved HOD, Dr. T. A. Sangeeta ma'am, coordinator of this FTP. On behalf of organizing committee and participants of this FTP program, I thank you, ma'am. Yeah, biggest thank you to the organizing team, coordinators, and technical staff who had work planning and dedicated behind the scenes who made today's event successful. It's my honor to extend special note of gratitude to all our participants, faculty members from various institutions across the country. Thank you for your enthusiastic registration and presence. Your commitments to staying at the forefront of technological advancements in education is commendable. Last but not least, I thank everyone who contributed directly or indirectly to making this inaugural function a success. Let us now move forward with excitement and into the FTP journey as we explore how generative AI is shaping the future of Industry 6.0 and redefining the academic and industrial landscape. Thank you once again, and best wishes to all for a meaningful and enriching learning experience. A happy learning to all.
Thank you, sir. Now we move on to the most awaited part of today's program. It's my honor to invite our distinguished resource person, Ms. Abhinaya Kamalakannan, IT Analyst, Tata Consultancy Services, Coimbatore, to deliver the session address. It gives me great pleasure to introduce the eminent resource person joining us today. Ms. Abhinaya Kamalakannan, working as a IT Analyst, Tata Consultancy Services, Coimbatore. She has 10 years of experience in IT sector. Her work has largely revolved around the ETL process, extracting, transforming, and loading data, but with a heavy emphasis on automation. She has worked on many tools like Pentaho data integration, Talent, Sysens, Tableau, and many AWS services like Glue, RDS, Lambda, DynamoDB, Amazon SageMaker, and building ETL pipelines out of it. A highlight of her career was receiving an Extraordinary Performer Award from CEO in her previous role with Kantar Analytics. She was proficient in Python, SQL, and PySpark for data processing, analysis, and pipeline development, and it's been a fascinating ride as an AWS data engineer. She received an on-the-spot award for her contributions in developing ETL pipeline that fully automates her insurance workflow using AWS services. With her vast knowledge and expertise, we are sure this session will be enriching and insightful. Ma'am, we warmly welcome you to share your thoughts on demystifying generative AI. Welcome you, ma'am. Now the session is yours.
Thank you. Okay. First of all, I would like to express my heartfelt gratitude to all my teachers and mentors. Because of them, I'm here today. Let's get started. Share my screen. So, able to see my screen, right? Please let me know.
Yes, yes.
Yes, ma'am.
Yes, ma'am.
Yeah, thank you. So today we'll talk about the demystifying Gen AI. So nowadays, wherever we go, when we step out of our home and we go, at least a word we'll hear about AI, right? So what is AI, and how AI is involving in everyday activity, whatever we do. So imagine you have a friend who is very knowledgeable. So whatever you ask him the questions, he is able to answer and do things for you. So that's how AI works. Like when you ask a question, Gen AI will give you an answer from the internet, whatever it searches, and give you an exact answer. So to understand Gen AI better, we have to see how Gen AI has evolved. AI is not a new word coming in 2025. It has started in from 1950s. So why Gen AI has become very popular now, and everyone started speaking about this. So for this, we need to know about the history of AI. In 1950, Alan Turing, he has come up with the question: Can machines think? So it started with a test like called Turing test, where it involves three persons, uh, a human interrogator, a human respondent, a human and a computer. So they were in three different rooms. Okay, so um, the judge will ask the questions, and the role of the computer is to give a human-like responses so that it can deceive a judge. The judge can think, yeah, it's the answer provided by a human and not a machine. And the same way, the human has to think, give a correct answers to the judge. So that's how the Turing test started. Till now, there are many debates going on. The Turing test has passed completely, but for for AI, it is a upcoming learning journey. After ChatGPT comes into picture, right? So it is able to give most of the. It has able to pass the test like almost like 70% and not completely. So with chat gpt when it comes, but in now chat gpt we are able to get answers for all. How is it possible now and why it is not possible in 1950s? Because in 1950s computers were very slow. It will not be able to answer or compute large amount of data because it has a very minimal compute power, right? So we used to have only cpus, and cpus will be able to process the information like sequentially. But after the coming of video games, we have come to a topic of graphical processing units, gpus. And the key idea of GPUs is parallel processing. So with a parallel processing architecture, like parallel processing thing, the computer will be able to do large amounts of data. It will be able to process a large amount of data in a recent days. That's the only idea. Like between the 1950s, we don't have that much compute power to process the data, and now we have large volume of data. Even we have large volume of data through GPUs and high compute power, we will be able to process anything. So that's why in 2000 in recent like ChatGPT on 2018, no, the launch of the first GPT model was a boom, right? After that only we started hearing about ChatGPT and other AI models, and we started using them. So once you give a prompt to a Gen AI model, it goes into the internet search and give you the answers in a fraction of seconds. How is it possible now? It's because all due to the compute powers the recent technology has. Okay, so now we understood, like till now we have started with an AI journey. We will know into what are the AI concepts we have. So AI is an umbrella. Under that we have machine learning, deep learning, and Gen AI. So if we want to say put it in a simple terms, what is an AI? So uh, AI is like a robot, okay, right? So if you any ask questions, it will think and respond on its own. But how it has been done, how it is able to think and it is able to answer questions. So if you take a a baby who is starting to learn things, right? You will show the flashcards to them for it to understand, this is an apple, this is a banana, like that. It You will feed the data, you will show the words, we will ask them to learn. So similar kind. So uh, we will train the AI model. We will put lot of data and pre-train the model. So then the AI will act upon it. It will think and it will learn on its own. I wanted to just share a Python program. Let me. So I have a Python program. Okay, so this basically what it does is like it is trained only on 3 fruits: apple, banana, and lemon. Okay, so I just wanted to feed information to this program to start with how Gen AI works on in a very it will work on a very high level, but I want to show it in a very simple by starting with the Python program. So it is asking the name of the fruit to get its description. If I say apple, so it is asking me a question like apple is typically a red or green and has a sweet and crisp taste, because this program knows about what is an apple. If I give another fruit name guava, it says sorry, I don't have information about the fruit. So I just wanted to add the information to this. I want to add this information to this program. So I'm giving a S. So it is asking, I don't know that fruit, what its name. I give guava and it is asking what color is a guava, green. So what does a guava taste like? If I give sweet, thanks, I have added to my list. Now if I want to give a description of the guava, it will say guava is a typically green and has a sweet taste. So it is a basic Python program. So like this, we are training the models. We are training the data. So that's what Gen AI it has when recently models has been pre-trained on large volumes of data. It will be able to create a content, summarize, automate things, and create images out of it. That's why AI is called as a multi-model. So we will go to the subsets of the AI. So AI helps us to do a reasoning, problem solving, and decision making, because it has a machine learning, deep learning, and generative AI. So we will learn what is a machine learning thing and deep learning and others. So if you go to machine learning, so machine learning will also be trained on a set of rules. If you have a cat's images and dog's images out of it, we will label them. Okay, so it is a cats, and these are the images for dogs, and when you feed into the machine will start labeling them, and it will able to identify the images. So this used to improve it builds methods so that the machines can identify its own models whenever a new image is given to it. Okay, it is so if you when we discuss about deep learning is like it's a human brain. It works like human brain. So it has a neural networks out of it, and it also uh, identifies the images and those things. If you want to put a classification between a machine learning and deep learning, machine learning is like a broader field of like biology. Okay, so but deep learning is a specialized and advanced topic. So within that, like neurology. So um, so machine learning is a computer. It learns from the data, the patterns. It identifies and it makes a analysis out of it and builds it produces the output. But deep learning is type of a machine learning that learns from a data using a structure that is similar to that of a human brain, so that it will be able to handle a more task with less human help. So is there any doubts till this point?
No, ma'am.
Okay, so
You can
if we
proceed.
okay, thank you. So if we work on a machine learning model in any industry, how it will be get started is like you will receive a lot of data. We will be pre-processing, we will be cleaning up those data, make a proper data set out of it, and we will choose which model fits exactly what we need to do, and based on that we'll proceed. So that model gives output. There are lot of analysis, data cleaning, and all the things or process. It is a part of machine learning, has its own steps to be performed to give a proper output. So all these things, machine learning use cases, the image recognition, NLP, recommendation systems, predictive maintenance, like all these concepts are part of the machine learning use cases. We will see how everything works in the upcoming slides. Okay. Then the generative AI, when it comes to generative AI specifically, it can generate a new content. For example, when you give the new words to the Gen AI to search in the internet, it not only learns from that particular word what we give, but also it tries to learns the pattern out of it, and it will be able to search on its own, and it will give you the output. For example, whatever we use ChatGPT or Gemini for any new prompts, no, whatever the questions we ask in those platform is mostly called as prompts. So when we prompt it, it will basically generates new data out of it. There are many the use cases, mainly if you use ChatGPT or Copilot or something, it can help us in the code. It will be able to predict the next word without any patterns or its own. It will be able to recognize its own patterns and search and get the output. So basically, generative AI can generate new content in a very sophisticated way because it is trained on a massive amount of data from the internet. So think LLM. The LLM concepts are emerged when we talk about generative AI. LLM is like a very smart student. When you allow that student to go inside a library and learn all these books, whatever in this library, you learn everything. So the LLM also learns whatever we feed. It learns all the books from the library. And when you ask a question to that LLM, it will give you an answer. Okay, because it is already pre-trained on the data, whatever is it, from the library. So the same way, the LLM, whoever built LLMs, or they pre-trained a vast amount of data from the internet so that LLMs can answer all the questions, whatever we ask them. So if you see in a deep learning, in a very deep dive, when we deep dive into it, we will have a artificial neural network. So neural networks, it has a very architecture, it has lot of layers, like neurons, like architecture. It will interact with each other to give output, like whatever it is expected to give. So each layer, for example, if we give an image of a cat to the deep learning model to analyze this, so it will take a very small features of the cat, and it will analyze it and make a complex features or image, or like that. It clubs all the shapes, whatever it recognizes from that image, so that whenever a different image provided to that model, it will be able to analyze it. It is a cat or a dog, because it takes a very deep level of understanding that image based on all the data it is able to collect from that image. So we'll see how example between a machine learning and a deep learning. So if in a machine learning, if we have an input where a problem statement, we will train that machine set of rules. For example, if this is a problem statement, this is an equation. So we'll give this equation so that when the next input comes, it will be able to give the output. So it is defined on a predefined set of rules we gave into the machine learning. Okay, so there are many so it will able to look at the input and output pairs so that it makes a connection, and this makes the computers perform in a more powerful way in a machine learning, because it acts it works the it works on a linear regression, or it has its own algorithms which is running behind every machine learning model. If you take a statistical machine learning and deep learning, you have linear regression, random forest, and some kind of algorithms into it. But in deep learning, you will have a neural network, transformer architecture, like that. So we have different set of learning architecture in like regressions and supervised learnings and unsupervised learnings, which will learn supervised learning, it will be based on patterns, and without patterns, the unsupervised learning will make a it will analyze the data and make analysis out of it. But when we deep dive into the deep learning models, it captures an every image of complex features of an image, whatever we provide, and based on that, it makes an analysis out of it due to the transformer architecture model or the neural networks concepts. So there are very popular techniques for implementing generative AI, the generative adversarial networks, variational autoencoders, and transformers. So we will see that one by one. The generative adversarial networks. So this type of networks or a generative model, it has two components, mainly a generator and a discriminator. For example, the generator is always trying to mimic something. For example, if it is trying to mimic a painting out of it, or some fake painting out of it, the generator or the discriminator always try to identify whether it's a real thing or not. It is able to identify what is the whatever it is trained on that model, no? So based on that, it will be able to provide the suggestions to the generator, so that the next time when the generator creates, it will be able to provide a better image, so that until it is trained on a collection of real paintings. So this will stop when the discriminator will not be able to find a fault on a generator. So until this step, the generator is going to create a new thing, and the discriminator is going to give a feedback to that generator thing, so that the generator and discriminator always works like two components which is getting worked together to finally provide a output in a very real manner. So when we will go to the next topic on variational autoencoders, the autoencoders are also a generative model. Basically, it is used in the unsupervised machine learning. So it will take one data point, and it will trying to summarize whatever it has learned from it, or recreate a new versions out of it. So end of the day, generative adversarial networks and variational autoencoders all are deep learning models. They are going to generate the new data, but the key difference is their own architecture, their training process, and quality of the output they produce is going to vary. But a powerful architecture then comes with our recent all AI models is used like a transformer architecture. So transformer is a type of neural network architecture. It's designed to handle the kind of sensitive task for machines. It is going to read, unlike the older models, it is not going to read the word by word. It is like a group of people working on to translate a sentence. So they will take each word one by one, convert it to a tokens, understand the meaning of it, and they will understand the whole meaning of the sentence, and they provide a proper answer to the user who they asked. So the transformer architecture, it is having an encoder, the output, and the decoder part. So encoder always takes the input, process everything, and the decoder is going to translate the sentence. It's like the sequence of tokens or words. So in the transformer model, the self-attention mechanism is the powerful mechanism, because in a sentence, whatever it picks up, no, it gives the importance to every word in that sentence. So if, for example, in a word, it adds the weightage to each word and the complete meaning. It understands the complete meaning of a sentence, and then it provides the relatable output to the user. So as I told about the encoder, its job is to just read and understand the input sequence, and it takes a sentence and turns into a numerical representation, whatever it understands, and capture the meaning. So the same way, the decoder is to get that encoder's output, translate it, and it also uses a self-attention, because at the end of the day, it is going to give a proper output to the person. So as I said, they all work immediately, like whatever, when a prompt is given, they all work immediately to capture the words, their sentence, and then they'll search from the internet, and they're going to provide very coherent answers to us. So the same way, ChatGPT, Gemini, and other LLM model works. So that's why transformers have become a very powerful AI model, because it can learn fast. LLMs LLM, the large language model, can learn fast. Whatever information we provide them, it can go and search in the internet in a very fraction of seconds, and it will give answers to us. It has lot of neural networks which is running in the background to ensure whatever things we searched for, it is able to collect from the internet. So, but in the same way, does whatever it searches from the internet, everything is correct? It is not necessary, because whatever it is pre-trained on, it is able to give those answers. But if you talk about any current events and asking them to get it, it will not. If it will not in a position to give that, because it is not very trained on a basic current affairs or something. So does AI hallucinate us? Yes, obviously AI can hallucinate us. So we'll see about how GPT has evolved. So GPT is a generative pre-trained transformer. As I told, it is a large language model. It can perform a wide range of natural language tasks. If you ask to write a poem, it will write a poem. It will ask to write an essay, it is an essay. It predicts the next word, whatever based on the input, whatever we give, it will be able to get the content and predict the next word and out of it. But everything is possible for GPT because it is pre-trained. It is already trained on the vast amount of data. That is why it is able to answer. If we are not able to give if you ask any new question that is not pre-trained on, it is not possible for that. It might give a wrong answer also. That is a possible. So LLMs, so they so where LLMs are used in a variety of create contents. We can use it for marketing campaigns, technical documentations. If you take any customer support or a sentiment analysis, so ChatGPTs can help us because it is able to get whatever the questions can be asked to the customer team support or a virtual assistant. It will be able to help us. So nowadays we are using our mobile phones, Alexa, Siri, and we have so all these have, it is pre-trained on how to act, right? So it will perform only the same repetitive task. It is going to say whatever we ask. It knows how to answer, what to answer, because it is already predefined on how smart it needs to act on. So it will do as the same way, like whatever. It will not be able to do the different kind of task, but whatever we ask them, it will respond. So as we come on this, there is a types of AI. We'll see weak AI. So as I said, this Alexa, Siri, or recommendation engines, they will perform only a specific task which is trained on. So it will be not able to think in a very reasonable way whether it is correct or wrong. Whatever it is trained on, it's used to say. But the next kind of intelligence it is there, like artificial general intelligence, AGI. That is would be able to understand, learn, and apply knowledge across a wide range of tasks. It is able to solve problems and make decisions in a new way. But these are all like it's work in progress. Like we will be able to know how AGI and ASI works as a long-term goal. So they expect this quantum AI recently and agentic AI. They are expected to be behave like humans. As we come to the same point, can machines think? So machines, that is developing every year on every innovation. It is a debating story until like we get a very if we ask don't can a 3-year-old kid put a glass down, it needs to say no, it is very dangerous or something like that. So the AI has to answer in a very responsibility. AI needs to responsible way. It has to answer questions. So that is more important, and it should not hallucinate us. Whatever we read from the content of generative AI, it should be there should be some more meaningful to it, right? So all these things are important. So that is all under developing in progress state. We will come to know about the more enhancements in the future. If you see the models available, Gemini, ChatGPT, Claude, Llama, these are all models. So in few days back, we always, when machine learning concepts were in the picture, we talk about algorithms. Everywhere people used to say this term called algorithms, right? Now after this chat gpt and things got evolved, we talk about models. So what is the difference between algorithms and model? Why people are talking about models now? Algorithm is like a recipe. Whatever the set of predefined instructions you feed on, it is going to do. Model is like a cooked meal, like it's a cooked meal that is used to, it has its own the essence of what it's want to do. For example, linear regression, it is a algorithm. But when you use linear regression, whatever output it is going to give, the usage that is going to be a model. Gemini has different models. So models and their outputs were always in a very evolving state, because if you see the Gemini model, Gemini Ultra, Pro, Nano, like this, there are evolving models in every period of time based on their efficiency. So we always speak about LLMs. There is one more concept called SLM, the small language model. So LLMs has LLM. It's like it reads complete set of books from the library, but it requires lot of computing power and performance. But if you go to SLM, SLM is like whatever it's needed, it will pick up those things and it will learn out of it. So it will have a less compared to LLM. SLM will have more efficiency when it's not a best fit, but when we are slowly working on training a models, SLM can also be a option. So now when it comes to AI, people always speak about, you hear terms on NLP, natural language processing, LLM, and RAG, right? RAG is so NLP is like natural language processing. It is like the language that computers can learn. LLM is like a good, it's a student who learns out of that everything. And RAG is like if a person LLM has a limit at one point of time, it might not be able to get the latest content out of it. So during that time, the RAG, retrieval augmented generation, it is going to get the most relevant from information from the internet, and it is going to provide that information to the LLM so that LLM can answer us. So it all works together. So there is always a, nowadays we used to hear a word, can AI replace our jobs or like that. So but AI is not going to replace humans, but if we are not updated with AI, then people will replace us. So there are a lot of things upcoming, enhancements on AI. You would have heard this agentic AI, quantum computing. It's all coming as evolving. So we will be knowing about this in the future advancements. And so so we are concluding it now. So thank you for the opportunity. Thank you all.
Thank you, ma'am. Thank you, ma'am, for the enlightening session. Dear participants, if you have any queries or anything you want to clarify, you may kindly raise them now.
Good evening, Abhinaya. This is Suresh from Kongu Arts, placement officer. So I have a small doubt about SLM. Can you hear me?
Yes, sir.
Yeah. So nowadays the companies can adopt this SLM, or it's in developing mode. Nowadays we are all using this LLM as like AI model that can be used in Chat GPT like that. Whether SLM can be implemented in industry, or now it is in developing process.
Yes, sir. So SLM, so ChatGPT, how ChatGPT is used? So behind the model, they are using the LLMs concept. So same way, those who develop those things, they are also working on the SLMs. The Google also uses SLM. The few AI device and few related things, they are using SLMs on device or edge applications. They are efficiently used in smartphones. But I like LLMs. So I too have not much interacted with SLMs, but
Okay.
they are in use in the industry. They are in use. So
Okay. Already this model can be used in some kind of in industry, but
yeah.
not it will be generalized for all industries. Yes.
That is
Ah,
based on our requirements. Like if we need, for example, if we need a vast amount of data to be trained on, means we will go for LLMs. But
ah,
if we have a clear clarity on one thing, if this model has to answer, for example, very specific topic, this model needs to answer only on this question, then we can go for SLMs. In that case, your performance and efficiency will be higher. We don't want to waste much resources, and based on our requirements, we will adopt those things. So
okay. Okay. When we go for an specialized task or specialized thing, we can go for an SLM. That model can be implemented, right?
yeah, cost
Okay.
effectiveness. Yes,
Okay.
basically when we develop everything, we will always think about computing power, cost effectiveness. Based on that, which is best, we will pick that one.
Okay. Okay. Thank you so much for your wonderful insights. Touch about a lot of AI insights like ASI, AGI, and LLM and SLM, GPT, etc. Thank you so much.
Thank you, sir.
Participants, anybody want to clarify or anybody want to ask the doubts, can ask.
Ma'am, I have a doubt.
Yes, ma'am.
When compared with CPU, GPU is very costly when compared with CPU, right?
Yes, ma'am. Yeah.
Since it is going to process in parallel, it is costlier. So is it necessary to use GPU for implementing all the AI models?
Ma'am, when we come to the latest trends, no, so if you go to the real world use cases like healthcare industry or any other industry, for example, I'll tell a use case. If you for example, uh, in a healthcare industry, take up a person got admitted. It's a real use case has happened. So he has a specific type of, he came up with a specific type of disease. Okay, but there is no doctors can rule out like what that person exactly got, right? So in that case, how they will find out like what that actual person has got? They need to rule out each and every one, each and everything. So what they did was, whatever symptoms the doctors has come up with, they feed everything into the model, and whatever answers they got, they ruled out everything. So in that case, when you want to get answers on a large variety of data, sometimes you need to work on a billion amount of data to get an actual answers. In that case, GPUs will be a very uh, optimistic one, right? You will get answers in a fraction of seconds, because AI actually, when now it comes to when AI, AGI or ASA, whatever it may be, people will only expect the answers in fraction of seconds. If the chat GPT loads the data, it took 15 seconds, we will lose patience, right? So it has to give a answer in 5 seconds or 6 seconds. There is a timeout for this. So for that, we need lot of computing power. So in that case, we have to go for GPUs, because parallel processing, now parallel processing is the, like, many computers needs to work on many tasks. Even if you go on a technical world like Spark, everything, no, people want things to do in a very distributed manner, so that it the performance will be faster. Yes, ma'am. That's why we are adapting GPUs. So if CPUs goes in like sequential task, you will lose your efforts, and it will take single time to answer, process everything. You might get a very late answers that might not be very in a. It will not be might effective. There are many problems there. So people always adapt GPUs. Ma'am, you clear, or you'll have still any doubt on this graphical processing unit?
Vidya ma'am, it's clear for you? Anybody's having any queries?
Ma'am, we have a question from you.
Yes, sir.
Yes. They are asking that how does the prompt engineering influence GenAI outputs?
Okay. So prompt engineering is an emerging job. So it is a recent, everyone talks about prompt engineering and what is prompt engineering like. So when you want to, for example, if you want to do a digital marketing campaign or something related to that, you will gather information, right? So you have to, if you ask the right questions to the model like Gemini or ChatGPT, if you ask right questions to it, it will give you a answer. It will collect from the internet and will throw the answers out of it. So whatever we provide as prompts, right? It basically it is a tokens whatever we provide, and whatever it gets from that internet, the right questions what we ask, that is the prompt engineering. So
So as I said, ma'am, we need to go through the prompting, right?
yeah, we prompting is like the questions we ask. If you ask will if you go to the Gemini platform and if you ask any questions, explain AI to us, like similar small the person who doesn't understand or like that, it has to give an answer. So how very redefine and the valuable question we ask to the ChatGPT or any AI model, it has to respond in a similar way, so that we will build our journey, a route, a roadmap, or for anything out of it. Like that is what a prompt engineering is.
Yes, ma'am. Thank you so much for your clear explanation. Ma'am, there is another question. So,
Yes.
what are the skills that the professional needs to be needed while working with GenAI?
Okay. So if you take up any platforms, no, Gen AI comes as a additional thing, right? For example, if you go to Databricks, it has a Genie. So when you come into this Zoom meeting, right, you saw a AI champion on the side ask you to is a chatbot kind of thing. So any applications you use, they are having a one AI assistant. If you go to Google, for example, if you use VS Code, right? We all use VS Code to develop some code, but we can integrate it that with GitHub Copilot or AWS services also offering many related things related to Gen AI. For example, Amazon recognition, and there are many services out of it. Okay, so for if you want to develop a model also, there are few services which requires we need basic Python programming or Java programming and everything. They are like programs are the first things we need to know. Then slowly we will move into integrating with the applications. And nowadays, if you need any help on that about any programming language, now we are asking Python. Sorry, we are asking ChatGPT and Gemini to answer our questions, and they are answering. So nowadays, using all these tools, a programmer can become a better programmer. So that's what answer for your question, sir. If you go to any a tool, if you choose for learning program, there is always a AI assistant will be there.
Ma'am, another question is there. Ma'am, how about neural networks? They had participant had raised the question. How about neural network?
Yeah, so neural networks are a type of, it's coming under artificial intelligence only. So neural networks basically has the neurons, they talk about neurons and neural networks like. So whatever input we give them, right, they search that, they analyze that, they think and respond and give a human like responses to you. So that is the basic objective of the neural network. So this transformer model and everything all are dependent on the neural networks only. So for example, if you provide a image of a cat or a dog and ask to identify it, it it takes every it, you don't want to feed for that model like the cat has a pointy ears like that. So it takes a very complex features from that image and try to understand a very single pattern out of it, and it tries to answer your question. If you give another cat images, it is not proper or something. If you give 1,000 images, whatever it learned from that patterns and features, it will be able to answer you. That's what neural network does.
Okay, thank you so much, ma'am. Thank you so much for your explanation. Dear participants, is there any questions from your side? You can answer.
Ma'am, we can move on to the next session.
Thank you for your clarification, ma'am. Dear participants, share your valuable feedback.
Participants, if you can share, one or two can share your feedback with a few words. Gentle reminder, participants, if you can share the feedback with a few words, can share it. Okay, ma'am, thank you.
Thank you very much, Ms. Abhinaya Kamalakanan, ma'am, for your insightful and thought-provoking session. Your address has not only enriched our understanding of demystifying generative AI, but also inspired us with new perspectives and ideas. We deeply appreciate the time and effort you have taken to share your expertise with us today. On behalf of everyone, we extend our heartfelt gratitude. Thank you, ma'am.
Thank you, everyone. Thank you all for the wonderful opportunity.
Thank you, ma'am.
Thank you, ma'am. Now, we move on to the next session of our program. It's my honor to invite our distinguished resource person, Dr. S. Rajkumar, Professor and Head, Department of Analytics, Vellore Institute of Technology, Vellore. It gives me great pleasure to introduce our esteemed resource person for today's session. Dr. S. Rajkumar is Professor and Head, Department of Analytics, School of Computer Science and Engineering, Vellore Institute of Technology, Vellore. He holds a PhD in Computer Science and Engineering from VIT with specialization in digital image processing and machine learning, with over 15 years of academic and research experience. He has published extensively in reputed SCI Scopus Index journals and conferences. His research interests include image processing, computer vision, medical image analysis, deep learning, and machine learning. He has also guided consultancies and sponsored research projects funded by agencies such as DRDO, ICMR, and SPARC, and holds multiple patents in AI driven applications. Dr. Rajkumar is a senior member of IEEE, a life member of CSI and ISTE, and serves as reviewer, editorial board member for reputed international journals. He has delivered invited talks, organized FDPs, and conducted workshops on AI, deep learning, and image processing at national and international forums. Welcome you, sir. Now the session is yours.
Fine. Good evening to all. Can you hear my voice properly? And can
Yes,
you
sir.
see my screen properly?
Yes, yes.
Yes.
Yes, sir.
Thanks for the answering. Fine. So, what I am going to cover another 1.5 hour is starting from AA to generative AA. So that flow or the path I am going to give as a overview for you. Fine. Okay. First, I will start with the AI. So I hope everybody aware that the AI is the field now is booming everywhere. Fine. So what is AI? That definition and all is there in my next slide. Fine. So now you have to know is the field of study. So AI is the field of study. So in which the subsection is called as a machine learning. Fine. So what is machine learning also I will cover in the upcoming slide. In which the subsection is the deep learning. In the deep learning subsection is the generative AI. Fine. In which the subsection we can have LLM. Is it clear? So LLM is the subpart of our generative AI. This you have to know. Fine. Okay. For your understanding, here I have given the relationship between the AI, ML, and DL. Is it clear? AI and ML and DL. So I have did my BTech in the year of 2004 to 8. In that time, I have studied AI as a elective course. now you can see in your institute, of the curriculum of the any computer related branches, they are studying AI as the one of the core course. AI is the one of the core course. AI you can assume as a one tree. Okay, so that's the reason I have shown this picture in the form of tree. Fine. So in the tree, you are aware that there are many fields are there, root is there, then stump is there, then branches is there. Fine. In the AI tree, we have lot of branches. The branches only we are going to, we are made as a now elective, or the branches is the subsection of the our artificial intelligence. So nowadays we have lot of technology. The technology is a comprise of AI. So rather than learning that AI whole, that AI you are going to learn as a whole topic, that is never helpful for when you are going to solve your real world problem, or when you are going to solve some specific problem. So you want to solve some of the specific real time problem, we have to know in-depth concept on the AI. So in-depth concept on the AI is the one of the concept is called as a machine learning. So machine learning is the support of the AI. So this machine learning is a one of the branch in the AI. So what I am trying to say, in recent trend, rather than studying whole about the trees, we are going to study only one branch in depth. That's will helpful for you to survey in our real world, okay, or to solve our real time problem. Is it clear? So machine learning is the support of the AI. So that is one branch. So if you want to learn about that particular branch or particular branches, you can study that rather than studying AI. Fine. No, sir, I don't want to know the machine learning. I want to know generative AI. So generative AI is the another sub branch. You can study that. Okay, the next branch is LLM. Even now you can see in many of the institute, we have the computer science as a specialization AI and ML. Computer science, we can have specialization as a data science. Basically, computer science is a specialization as a generative AI in future will come. Generative AI or large model will in future will come, because they are support. They are able to solve more amount of problem than the ML algorithm or than the AI algorithm. Is it clear? In future, you may get NLP also one of the sub branches. Okay. So what I'm trying to say, in the A, the sub branches is called as these are the special topic, or A sub branches is these are the field. Now is boomed or booming. Okay, in our India is booming, but in other foreign countries and all, many of the topics are already boomed. Is it clear? Because there they have all the field or all the configuration, all the technology, everything they have more than the India. But India now is booming. India may will lead after a year, after the 10 decades. Okay, after the 10 years, may India can lead the other countries also. So like that, now it's booming. Fine. Okay. Now with that introduction, now I am move on to what is AI. So AI is nothing but the one of the branch in our computer science. What it will do? So AI is a one machine that try to perform like our human being. So that try to do work like our human being. Okay. So the formal definition of that is there in the next slide. Just you should know AI is the computer science field. So it's what it will try to do. It's try to create the machine. That machine going to act like our human being. It's a clear act like a human being. So that machine, what's going to do? The machine going to do, or the machine going to have, the machine has the algorithm. That algorithm, what it will do? It will do learn, or reasoning, or making the decision, or solving the problem, or understand the language and perspective their environment. So what is that AI is basically going to do? It's going to do some decision making problem like our human. or it's try to solve the complex problem. Is it clear? So for that, we are going to design some algorithm that is called as a AA. Okay, fine. What is the formal definition of the AA? There are many people are given the formal definition. Okay, hereby I have given. Okay, if you want, okay, you can later you can refer. I will share the slides with the organizer. Okay, fine. So I will take only one example. The first definition for AA. AA is the automation of the activities. That's all. So it's going to do automate our activities. It's what it's going to do, AA, automate our activity. Okay, so that's you have to understand. Fine. Rest and all I will skip. Okay, so you may refer later. Fine. You know, AI is going to do automate our activities, our day-to-day activities. Fine. Okay. So how that AI we are going to represent? So you are known AI is going to do automate. For automation, we are going to represent the AI model. How you can represent the AI model? In the older days, our very basic AI model is first order derivative is the basic AI model. Okay, first order derivatives. Okay, or sorry, first order logic. So first order logic, you might be studied in your discrete course. Is it clear? So in the discrete course, you have studied if then else rule is called as a first order logic, or AND gate or OR gate logic gates. They are first order logic. Is it clear? Sir, you have studied as a tautologies or contradiction or contrapositive. This is another first order derivative logic. Okay, so initially we started the AA with a simple logic rule. Is it clear? Even that logic, whatever you are define the logic to solve the real problem, that is also called as a AA. That is called as a AA. But what happened in that AA model? Is there any disadvantage? Is there any limitation? Yes, we had the limitation in our first order logic. What is that limitation? Using the first order logic, you can't solve all the real world problems. Please note down, using the first order logic, you can't solve all the real world problem. Is it clear? So to solve more amount of real world problem using the computer, we need better mathematical model. So that's why the AI is moved as a like anything. So what are the better mathematical model they have used to develop the AI? So they have used higher order logic and logic programming, frames, production rule, semantic networks, fuzzy logic, Bayesian network, hidden Markov model, neural network. These are representation of the AI. These are some of the representation of the AI model. Apart from that, even other techniques also there. Even other methods also there to represent the AI. For your understanding, this is fine. Is it clear? Fine. Next, how you can implement this AI? For implementing the AI, we have some of the specialized AI program. Specialized AI program. They are Prolog, Lisp, and ML. Okay, these are initially when the AI comes up, that time initially is developed with this one. Initially developed with this one. These languages for to solve the real problem using AI language. But nowadays many languages are boomed than this. Okay, specifically now we have the Python. We have Python. The Python can solve any problem. Sorry, you can implement the AI model using the Python. So Python is the extended language or extended version of our AI programming language. Is it clear? Before the Python, we had many languages are Perl, C++, Java, and Julia. Julia is specifically developed for this one. Okay, but even if we have these many languages, but now people are using Python. Reason is Python is the open source, and also all the packages are you can easily implement. Sorry, you can implement easily. Then another reason is the Python codes are the Python code interpretation take is less time than the other programming language. So that means you can execute your program very faster way. Okay, so that's the reason now many people are implementing the AI model using the Python. Okay, fine. Now how we can briefly classify that our AA. So AAs are classified in two different way. One is cognition and learning model. Another one is perception model. Another one is behavior. So if I go with the perceptual model, there we can have the topics of NLP and computer vision. So if your guys are if you are studying one course NLP also is sub branch of AI. So but that is specifically for natural language process. So similarly, you want to do any video or image processing task. So that is called as a computer vision. Is it clear? So here the perception is given in terms of input, in terms of what kind of you are going to give. Okay, fine. So if you are having this type of input, you want to solve this, we need some model. So that's we have given as a here cognition and learning model. So the cognition and learning logic I already said just now. And planning, knowledge representation, reasoning, probability is Bayesian theory. The another one, the subfield is called as a machine learning. Even we have these many subfield, among which machine learning is grouped like anything. Now this machine learning is classified based on the learning in the terms of supervised learning, unsupervised learning. Further, we can have deep learning, reinforcement learning, transfer learning. Okay, so these are all sub branches of the machine learning. So now the AI is subdivided into this much, in which we are going to cover machine learning. Model. What is machine learning is given here. Machine learning is the subfield of our AI model. So what is this AI model is going to do? This AI model able to learn the data, or this model provide the machine. This machine learning model will provide the machine. That machine, how will get the input, learn. So this will get the input with the user. See, please note down. It able to learn. Through the input without any explicit programming. Please note, machine learning is the subfield of AI. This machine learning can get the input in the terms of data, or in the terms of rule, or in the terms of or in the term of data, rule, or instruction. Is it clear? So this machine learning able to learn, learn from the data without explicit programming. So what I am trying to say, for machine learning, for learning purpose, or we no need to do any programming at all. No need to programming at all. And how these machine learnings are evolved? These machine learnings are evolved from our mathematical model, computational learning theory, and pattern recognition. Okay, so from that it's learned. Then what is the formal definition of the machine learning is given here. So the it's given here, which is defined by the Tom Mitchell. Okay, Tom Mitchell. The Tom Mitchell is defined the machine learning with a 3 parameter. One is E, another one is T, another one is P. So what is E? E is the experience. What is the T? T is the task. P is the performance. What does that mean? E. So E means you are going to do the learning. E is learning from the experience. Is it clear? That is your input. Fine. For that input, or from the input we learn. For the learning, we have to get some target, or output is called as a task. Okay. From the data, we are getting some target. So if your target is not effective, or how do you find whether you are achieved the good result or not for our given data? In order to do that, we have to evaluate the performance. That is called as a P. Okay, that is called as a P. So through the P, we are going to improve the learning. If we improve the learning, we can get the good accuracy, or good model, or good result. Okay, that is called as a T. So E, T, P. So these three are playing the role. to define the machine learning. For your understanding, I have given one example problem. For that problem, how the machine learning going to act. Okay, so what is my problem here? Yeah, chess learning problem. Yeah, chess learning problem. So you are going to do chess learning problem. Is it clear? Chess learning problem. So in this problem I am going to define with the 3 parameter. One is ETP. What is E? Is experience. Here, what is the experience? Keep on, you are going to practice playing the practice game against itself. Okay, so you have to play the game by yourself. You have to play the game by yourself. Okay, so that is the E. So keep on, you are going to play. Okay, through that you can get some knowledge. Basically, that is E. Now, target. What is your target? Playing the chess. Playing the chess. Okay, playing the chess. What is the performance measure? Your percentage of games you won against the opponent. Percentage of games you won against the opponent. Is it clear? Percentage of games you won against the opponent. So the learning, how do you evaluate here? So based on number of times you won the game. Is it clear? So based on that, we are going to perform, or you are going to update your learning model. So this is one of the typical example. What is the another typical example? Here, typical example I have shown here is automatic driving car. You know, now Tesla or many companies are developing or inventing or creating or establishing the car without the driver. That means automatic vehicle car. Okay, so here what is their objective? So they want to run the car on the public road without the driver. So here what is the experience, or what is the data to learn? The data to learn the steering commands. Okay, so along with the steering command, we have to give sequence of images, whatever the car going to see in front of the on the road part, on the road. So we have to give the experience. Okay, the image of this road, then steering command, as well as the human driver, while observing the human driver, recorded human driver command. So these are the 3 things we have to give. Okay, based on that command, we are going to test that. How we have to test? We have to check the performance of that model based on number of time accident is happened. Based on number of time accident is happened. Okay, so that is the performance. What is your task? Here we have to make the car to run on the public highway road or public roads. Is it clear? Using vision sensor camera. Is it clear? Now in this slide, I am going to give what are the different ways we can give the input to our machine learning model. One is learn from experience. We can feed the data, learn from the experience. Is it clear? One model for feeding the input to our machine learning, learn from experience. Okay, the second one is follow the instruction. The third one is learn from data. These are the 3 ways we can feed the input to our machine learning model. Fine. Okay, now I will move on to what is the difference between AI and the ML model. In AI model, so what we have to in AI model, or through the AI model, you are going to solve some of the real problem. So we have to feed the input as data. We have to input as data. Data means your input, as well as the logic. Using the data, what you are going to do. That logic we have to give. Answer we will get for the given data based on this rule. What is the output you are going to get? That is called as the answer. For one example, for your understanding, So you want to perform addition of two number. You want to perform addition of two number, or you want to perform among the given two number who is the greatest number. So here, what is the data we have to give? Two number, A, B. So what is my task? I want to check who is the greatest number. So for that, we have to define the rule. What is the rule we have to define? The rule is greater symbol. Rule is the greater symbol. What is the output we will get after applying this rule on the data? We are going to get the greatest number. Okay, assumption A. So this is the thing you the traditional AI will. Then what is the ML will do? ML will do take the data A and B as well as take the output. So what is that ML will do? Take the input and output and bring the rule and derive the rule. This is the role of the ML model. If we see many people are saying ML training I am doing, or machine learning training I am doing, or machine learning I am doing. So in the machine learning, during the training, what happened? You are going to give the input as well as the output. So from the input output, the machine learning model will bring the rule, or derive the rule. In order to derive the rule, there are different kinds of ML models are there. What are they? That's I will show in the upcoming slide. I hope you now got it. The difference between traditional AI and machine learning. It's clear. Traditional AI and machine learning. The same thing is given for your understanding here in the different pictorial form. The form of different pictorial form is given here. Is it clear? Fine. Now, next, I move on to when do you have to use the machine learning model? We can use the machine learning model wherever the human expertise can't go. There you can use this machine learning model. Or wherever our human is unable to explain something, there you can use the machine learning model. Or when we have the amount of data are more, so there we can use the machine learning model. So basically, when do you have to use the machine learning model? Where the human expertise can't go, or wherever we have the inputs are more. Okay, so there we can use the machine learning model. What is the application or application of machine learning model? See, one of the application is classification of the email message, or we can do computer vision task, NLP task, recommendation system we can do, or prediction we can do. Okay, prediction of gold or stock price tomorrow based on past data. So these are some of the application. Apart from these, many applications are there. So there you can use the ML model. Okay, fine. Now I move on to ML in a nutshell. ML in a nutshell means the simple overview of the ML model. Okay, simple overview of the ML model. Okay, around 10,000 of ML rules are there right now, or ML algorithms are there. Every year, around 100 new ML models are developing. That ML model, every ML model has a 3 component. Please note on all the ML model has 3 component. One is representation, another one is the evaluation, next one is optimization. For your understanding, I will relate this one with our data structure algorithm. You have data structure algorithm, one of the algorithm bubble sort. Fine. And how we can evaluate the performance of the bubble sort? Using their time complexity. Fine. So through the time complexity, we know bubble sort will take time order of n squared. So to optimize this model, or to optimize this algorithm, we have used algorithmic strategies. What are the algorithmic strategies are there? Divide and contour, dynamic programming, backtracking, and so on. So they are called as a optimization algorithm. Divide and conquer is called as a optimization algorithm. So in the older days, to optimize our traditional algorithm, we had some of the algorithm strategies. Like that, to optimize our machine learning model, we have some of the optimization algorithm. Okay. So what are the algorithm that I will show in the upcoming slide? Okay, or after the 2 slide. Fine. Before go for that, first we'll see how to represent our AI model. We can represent our AI model, sorry, or we can represent our ML model using decision trees. So you can represent the ML model. One of the basic model is decision. Second one is you can use some set of rules. So you have to define the some rule or instance or graphical model that is called as a Bayesian network model or neural network model, support vector machine or ensemble model. These are the using these method or using these representation, we can represent our ML model, Okay, these are some of the ML model. And how do you evaluate the performance of these ML model? So these are the metrics are there. These are the metrics are there to evaluate the ML model. When you are going to evaluate this model using these metrics, if your metrics values is less or more, depends on your application. So depends on your application, you may get less or more value. So if you are getting the result by getting the result and evaluated that using this metric, when your results are very less or more means over, more than the threshold. So that time you want to optimize your model, this model. For optimization purpose, we can use some of the optimization technique. One of the traditional optimization technique we are using in all the ML model is gradient descent formula. They are using gradient descent formula very well. Is it clear? Through which we can optimize our ML model. Okay, fine. Next, how we can categorize this ML model? See, just now we saw what is ML and when we have to use the model, what are the application of the ML? Then followed by that, what are the components are present in the ML model? There are 3 components, among which one is representation, next one is evaluation, third one is optimization. So that representation we know, evaluation we have already studied, and optimization also we have studied. But how we can categorize this model or this ML algorithm? We can categorize, there are 2 ways our ML model. One is learning by style model, another one is similarity function, another one is based on similarity function. Now we move on to classification of the ML model in terms of different learning model. So what are the different learning models are there? One is supervised learning model, another one is unsupervised learning model, next one is semi-supervised, another one is reinforcement model. In the next slide we will see what are the different ways, in the next slides we will see the explanation about this learning model. Okay, first we will move on to supervised learning model. See, we saw the some of the representation. That representation, how we are going to train. So that is called as a learning model. One of the typical learning model is called as supervised learning model. Is called as a supervised learning model. Is it clear? Fine. So how we will see how this supervised learning model will take the input. This supervised learning model will take the input along with the output. Please note, it will during the training, it will take the input. Input is called as a data along with output. Okay, that is called as a supervised learning. So how we are going to classify our machine model based on how it's taking the input. So if the model is taking the input, both input as well as output, that model is called as a supervised learning model. Example for the supervised learning model is Tom and Cherry problem. So you want to classify from the given images, who are they, Tom and Cherry. So who are they, Tom and Cherry. So in order to do the classification, we are going to use the supervised learning model. We are going to use the supervised learning model. The supervised learning model, when you are going to use, that time we have to feed both input as well as output. In this problem, the inputs are called as these images. These are the images are called as a input. So what is the output? The output is called as, their name is called as output. Their name is called as a output. So their name is called as a output. So in our data or in our available data set, we have both input and output. So when I am going to use this kind of data in our ML model, they are called as supervised learning model. What is the supervised learning model will do? It will take this input as well as this output. It will take this input as well as out. This will take input as well as the output. Okay, this will take input as well as the output. This will take input as well as the output. So based on this input, our input and output, our learning model will learn, or the learning model learn this data. Our learning model learn this data and use this learning data for the testing purpose. Okay. So during the training, so what is the learning model will do? It will learn this image is called as Cherry. This image called as Tom. This image called as a Tom. Is it clear? It will learn this is image as Cherry and this is a Tom. Is it clear? So this is the learning is happened. Then during the testing, what we have to give? We have to feed only these images alone as a input. So from these images, okay, from these images are given to the our trained model. So what is the output we will get from the trained model? We are going to get that label is the output. So we are going to get the label as the output. So this is called as supervised learning model. The best example for supervised learning model, teaching learning process. Here I am teaching to you, you are learning. So learning is the output, the teaching is the input. Okay. How do you know what is the percentage of the learning is happened? Okay, whether 10% or 100% or 80%. Okay, that percentage is called as a label. The percentage is called as a label, and I am going to give the content that is called as a input data. Okay, input data. So now based on my input, you are learning. How much percentage of learning is happened? How do I do? How do I know? Based on testing. So what I have to do during the test? Just I will ask the question. I am not going to do the spin coding during the exam. So you are going to write your exam and you are going to get the score. Based on the score, we may say you are belongs to class 50% class, or you are going to you are belongs to the 80% class. Is it clear? So that is the one of the typical example for your understanding supervised learning. Then fine. So in the supervised learning here, I have given in terms of generative AI also I have given. Okay. So generative AI also, this is the one of the typical example using generative AI, how that supervised learning will work is given. Okay. So this is the generated input. You see this red color and blue colors is your data. Okay. And among this data, we are going to discriminate who is that red class, who is the blue class. Okay, who is the blue class. So for that also we can use the supervised learning. Okay, if you are not understand, no problem for this. You have to understand what is supervised learning. That's alone here. Fine. What is unsupervised learning? Unsupervised learning, what is the difference? Unsupervised learning means we are going to feed only input. We are not going to feed the output label. We are not going to feed the output label to the our machine learning model. Such a machine learning model is called as an unsupervised learning model. unsupervised learning model. What is the purpose of this unsupervised learning model? We can use this unsupervised learning model for the grouping purpose or clustering purpose. So here I have given only input. I am not given the output label Tom or Cherry. Tom or Cherry. Is it clear? Now from this unstructured data, what is the unsupervised model will do? It will try to do the grouping. It will try to do the grouping or clustering. So this clustering, you may take it as a label as this is 0 and 1. So now from the unsupervised data, we made as a supervised data using unsupervised algorithm. So if you want to use this unsupervised data for classification purpose, first we have to do the grouping or labeling. After labeling, this we have to feed as a input to the our support vector machine. Sorry, our supervised learning. Okay, so this supervised learning model will take this input as well as the label is called as a 0 and 1 as a output, and it will do the classification problem using a supervised learning. Okay, fine. What is semi-supervised learning? Semi-supervised learning is nothing but is a combination of supervised learning and unsupervised learning. Combination of supervised and unsupervised learning is called as a semi-supervised learning model. What is the another learning model is called as reinforcement learning. So in order to explain the reinforcement learning, I am going to take one example. Isolated island. Assume you are right now in the isolated island. So how you are going to behave based on your behavior, we are going to draw one state diagram. So that diagram we are going to use for the training purpose. That is called as a reinforcement learning. That is called as a reinforcement learning. Is it clear? Here in the reinforcement learning, how you are going to construct the model based on the action you are going to do in the island. So if I made you to stay, or if I dropped you in the island, what is your first objective there? Your first objective is you want to live in the world. In order to live in the world, what we have to do? First one is we need the food. So you are going to search the food. The food is called as input here. The food is called as input here. Based on the input you are eating, or you are based on the input you are going to perform something. Something is called as eating. So after eating, you are going to get the reward. You are going to get the reward positive or negative. Based on positive or negative reward, you are going to draw the state diagram. That is called as a reinforcement learning. That diagram we are going to use for the testing. During the testing, I am going to feed some input. So based on my input, the reinforcement learning model is going to give some reward, either positive or negative. If it is positive record is giving, you can use the data for solving your real world problem. It's giving the negative result, then we may say these data are the training is not sufficient. We have to still train. Okay, so that is called as a reinforcement learning. Fine. So in the reinforcement learning, what we are going to do? We are going to draw the model based on the input. Based on the input. Fine. Okay. So when you are going to draw the model based on the input, we are going to get the reward. If it is positive response, positive reward. If it is negative response, you will get the negative reward. And we are going to make some policy for that diagram, that state diagram. Okay, state diagram. Fine. So based on the policy only, our state diagram will behave on our test data. Fine. Okay. In addition to these 4 learning, we have another 2 more learning. They are called as a shallow and deep model. Shallow means we are going to develop one small model. In that model, we have only input layer and output layer. So that is called as a shallow model. What is my deep model? We may have input as well as many hidden layer and followed by output model. They are called as a complex model or deep model. This deep model we can use for our deep learning application. Okay. And now I will go for the summary of that learning style of our machine learning model. Okay, so the summary is here what kind of input will take based on the input. Okay, what kind of activity it will do, for that activity what kind of algorithm or what kind of representation we are going to use. So that is given in this slide. So you are aware that machine learning model we can categorize it to 4 ways. One is supervised learning, unsupervised, semi-supervised, another one is reinforcement learning. What is by supervised for the supervised model? How we can feed the input? We can feed the input. There are 2 ways. One is continuous form, another one is categorical form. Okay, in continuous form, you are going to give the input to supervised learning model. Such a learning algorithm we may called as a regression model. We may call it as a regression model. So you are going to feed the input to our supervised model in the form of categorical. Then such a model we may call it as a classification model. We may call it as a classification model or classification method. And in the unsupervised model, we are going to feed the input either continuous or categorical. Okay. Okay, we are going to give continuous or categorical, but we are not going to give the target or we are not going to give the output. Okay, in that we are going to apply some learning or some model. They are called as a clustering model or association model. Clustering or association rule. Okay, association model. Then semi-supervised model will take the input in the form of categorical target variable. Categorical target variable. There we can apply model or algorithm. They are called as a classification model or clustering model. And next one is called as a reinforcement learning. We'll take the input in the form of categorical with target or without target. Categorical with target is taking, then such a model we may call as a reinforcement classification model. You are going to give only data without target. There is called as a controlling model. There is called as a controlling model. I have given the I learned example that is called as a controlling model. Control. It's a clear control. So this is the summary about the A and ML. This I have given A already. And what is the ML? So this is the ML model. This is the ML model. And this ML model work in the 2 step. One is called as a learning model. Another one is called as a testing model. Learning model we may called as a training model. The testing model we may called as a prediction model. Okay, but in the traditional model, we have only the prediction model. We do not have any learning at all. Just we will feed the data as well as model. So based on our model, we will get the output, or based on our model structure, or based on the mathematical model involved on the our model, we are going to get the output for our given data. Okay, so in the traditional model we have only the prediction, but in the machine learning model we have both prediction and learning model. Okay, prediction and learning model. So in the under the machine learning model, we have one more model is called as a deep learning model. Okay, we have the one more model is called as a deep learning model. Now I am move on to the deep learning model. Now I am going to move on to the deep learning model. In the deep learning model, our deep learning is the subset of our machine learning model. Subset of our machine learning model. Fine. Our deep learning model, we can represent using or various way we can represent. One is called as artificial neural network, or CNN network, or RNN, RBN, autoencoder, GAN, unphase, or ensemble model, hybrid model, or transfer learning. These are model comes under deep learning model. Fine. Now I move on to the deep learning model. Now I have to move on to the deep learning model. Okay. And before move on to the deep learning model, under the machine learning only, we have the generated model. See, under the machine learning only, we have the deep learning model. In the deep learning, we have one of the model is called as a generative model. In the generative model, we can make either in the form of deep model or you can make in the form of swallow model. If your data is small, we can use swallow model. If your data is more, we can use the deep model. Okay. Now I move on to the deep learning model. So deep learning is nothing but the subset of the machine learning model. It's a subset of the machine learning model. Is it clear? And this model uses the artificial neural network with many layer, with learning many layer. Is it clear? With many layer. So deep learning is a subset of machine learning, and that model representation in terms of neural network model, artificial neural network model with the many layers is called as a deep learning model. Okay. When do you have to use the deep learning model? Here you can see one of the typical example here. Okay. In this example, there are two kinds of images are there. One is puppy images, another one is toggle images. So when you have the input like this complex or similarity one, so on this, if you are going to apply any A and ML model, you can't get the 100% correct result. You can't get the 100% correct result. So if you want to get the 100% correct result, instead of using machine learning, we want better model. We want the better model. So the better model we are going to use here is called as our deep learning model. So deep learning model basically we are going to use when you have the complex data. Fine. The next one is example is called as a sheepdog or map. Is it clear? So when you want to classify sheepdog or map, for even you can see in this example, the map and sheepdogs are more or less same. So in which you want or in this data you want to classify map or sheepdog, also it's very difficult using a traditional AI and machine learning model. So for that purpose, we need better model. The better model we are going to explain here for the solution of this problem is deep learning. Okay, and we have the deep learning model. Fine. This deep learning model. Fine. This deep learning model. Fine. When do you have to use this deep learning model? When your data amount of the data is increasing, and on the increased model, you want to do some activity. So for that, if you are going to use traditional our AI or machine learning model or any neural network model, their performance are low. Okay, their performance are low. You can see here when my amount of data are increasing, that time if I am using my traditional model, my performance is only this much level. So maybe you can take it as 40%. When you are going to use small NNN, you are going to use 50%. Okay, when you are going to use the large NN model for large data set, there is the chance for getting the accuracy 90 plus. So when do you have to use that deep learning model? When the volume of the data is more, and there in the volume of the data, the complexity is more, we can use the DL model. How we can represent this DL model? We can represent the DL model. There are different ways. Here some of the representations are given. Okay, they are, one is recurrent neural network, another one is longest short-term memory. The next one is called as a convolution neural network. Next one is called as a deep leaf network. Next one is called as a deep sequential network. Is it clear? So these are the architecture or exist in the deep learning model. What is the purpose of these architectures are given here? We can use RNN model for the speech recognition application or handwritten data recognition. LSTM model we can use for natural language recognition, or we can use for text compression or gesture recognition or image captioning. You are going to add the caption for the image. So for that purpose, we can use LSTM model. Then we can use the CNN model for the image classification or video analysis, or we can use for recognize the shape on the or recognize the object present on the CNN on the images using CNN model. Then what is the use of deep belief network? Retrieval as well as natural language understanding and failure prediction. And deep sequential network we can use for information retrieval purpose. Okay. Now I am showing here the typical representation of the CNN and RNN. So this is the CNN model. This is the RNN model. Is it clear? The CNN model. So this phaser is called as a feature extraction space, and this phaser is called as a fully connected layer model, or we may call it as a classifier model. This classifier model. Okay, fine. In recurrent neural network, we have the model in the form of input, hidden layer, and output. Okay, this is called as an unruled model. Okay, this is called as a ruled. Fine, this is unruled, this is the ruled model. Fine. Okay. So this is the representation of the CNN and RNN. The remaining things, the remaining model, you can check it on the Google, or you can check it on the prescribed textbook. Okay, prescribed textbook for the deep learning. Okay, fine. Now we move on to what is the difference between ML and DL. So in the ML and DL, what is the major difference? So in the ML part, you cannot give the input directly in the form of images or video. In the ML part, you can give the input only in the form of categorical form or continuous form. If you want to feed the input in the form of if you want to feed the input in the form of images, that is not possible. But you can convert the images in the form of some vector or some categorical form. Then you can feed that data for the ML classification, and based on the data you are extracted from here and feed it to the classifier, the classifier will perform based on the input feature extracted by the human. If your extracted feature is less or insufficient, my classifier performance is slow. Gets slow. So this is called as a machine learning. So why it's slow? It's based on feature extraction by the user. Feature is nothing but the data you are used for machine learning. Okay, from the data, we are going to take only the recovered for the classification model. Is it clear? So that is called as a machine learning. But when I am going to use the input extracted by the human, that the extracted feature will either may or may not will give the good result. If they are okay, may or may not give the result. But this may or may not result is fully depend on this guy. So that is mean by extracted by the user. If the extracted data is not good, then this accuracy is degraded. The performance of the machine learning will be degraded. So in order to avoid the degradation of the performance of the machine learning, we have developed the deep learning. In the deep learning model, what is the advantage? The deep learning model, we have the advantage, okay. What is the advantage? We can feed the input in the deep model directly in the form of images and video. But in our machine learning, we can't feed the input in the form of images and video. Okay. if you want to feed the input in the form of images, we need the deep learning model. That is one. The second difference, okay. So the classifier performance is fully dependent on the feature extraction, by the user. If the feature is not good, this classifier performance is less. So that's the reason what we did, the deep learning, just we give the input and allowed the deep learning model itself extract the record feature, and that features are given as an input to the classifier. And these features are given as an input to the classifier. Is it clear? And these features are extracted by the machine. This feature performance surely is surely better than our human extracted. So that's the reason we are going for the deep learning. The second reason we are going for the deep learning for extracting the feature automatically. Fine. And the third reason why we are going deep learning model, when you have the complex data, when you have the complex pattern, so there you want to do classification or prediction, we need the deep learning model. Okay, these are the three things we have to know. Fine. And how this deep learning model will relate with our generative AI. So first AI, in that subpart is ML. In that subpart, we may have the deep we may have the subpart is generative AI. Now we move on to the generative AI. Fine. Now we move on to the generative AI. So how we can do the learning on the generative AI? So for the learning of the generative AI, the first step, we have to use any one of the generative AI terminology. We have to use any one of the generated AI terminology. One is AI or machine learning or transformer or prompt engineering you can use. Is it clear? Fine. Now, after feeding the input, then we have to use some API model, or we can use some API model for learning of this. Okay, we have some built-in API model. One is OpenAI, Hugging Face, Vertex AI, and API best practice. Fine. So these are the APIs we can use to run our generative model. So a generative model is we can develop using these things. Okay. And that for developing API model, we can use this thing. And where you can use the generative AI model, we can use for education and learning purpose, or business and financial purpose, and marketing purpose. Now, this application we are extended in the format of RAG model and fine-tuning model. Okay, fine. Now, what is the definition? This is what is it? Learning generative AI. Then next we are move on to what is generative AI. Generative AI is a branch of artificial intelligence. What it can do, it will try to create the new data. It tried to create the new data. Okay, fine, from the existing pattern, from the existing data. So that is the generative AI is doing. Fine. Is it clear? What is the generative AI is doing? Will generate the new data from the existing data. Is it clear? Fine. Okay. Now, what is the challenges in the generative AI? When you have the complex pattern, or when you have the unstructured code, okay, so that time we need generative AI. So generative AI is better than our deep learning model, or generative AI is the subpart of the deep learning model. That's we have to know about. But when you have to use generative AI, when you have the unstructured input, or when you are when you want to understand the complex data. Fine. Okay. Here, the Richard Feynman says, what I cannot create, I do not understand. See, what I cannot create. What I have can't create, that is he is saying I can't, I cannot, I do not understand. But what is the generative AI model is saying? What I can understand, I can create. What I can understand, that I can create. What I can understand, that I can create is called as a generative model. Okay. What are the issues in our CNN and RNN or LSTM? Because these are all popular deep learning model. Here we have the one of the first limitation is not in these models are not efficient to handle the multi-model input. Please note to handle the multi-model input, this model can't work. So we want better model. So that's why we need the generative AI model. So that is one reason. Another reason, when you are going to use this model, there is the chance for getting the vanishing gradient problem. Vanishing gradient problem. Is it clear? So to avoid these problems also, we are going to use the generative AI model. Okay, generative AI model. What is generative AI? Generative AI is nothing but it will create the new content from the existing data or trained data. So that is called as a generative AI. You can see generative AI is referred to a set of artificial methodology that can produce novel content that resemble the training data. So from the training data, it will generate. Okay, what can generate? It can generate synthetic text or generating the code or realistic images or music and so on. Music and so on. So this is the thing will generated by the generative AI model for your understanding. So here your voice example, the generative AI will generate the new content. Okay, and what are the key features are in Gen AI? So in Gen AI, there are 4 key features are there. One is content creation. Yes, obviously we are going to use the generative AI for the content creation. We are going to use the generative AI for the content creation. And based on large model, based on large model, we can create. Based on large model, we can create. Okay. So in order to create that large model, we are going to depend on the basic model is called as transformer. Basic model is called as a transformer. Is it clear? Basic model is called as a transformer. Is it clear? So through the transformer, or the transformer is the base model for the generative AI. What is transformer? That I will explain in the upcoming slide. And what are the layers are there in which? Fine. And what it will do? Trained on massive data set. So if you want to train the large volume of data, this you want. And human-like creativity. This generative AI will create or can simulate like the human. It will generate the data. So what do you have to remember there? The generative AI, we develop the generative AI, we need a basic model is transformer. The fundamental model for generating the generative AI is called as transformer. Please note that. Okay. So this is one of the basic model. Fine. Now, so through which what is the generative AI will do? It will create the new content. It will create the new content. Okay. How this generative AI differ from our traditional AI? Our traditional AI, what it will do? It will get the data and then analyze the data. From the analysis, we can use that analyzed data for prediction or classification purpose. But what we can do in the generative AI, we are going to generate the data. We are going to generate or create or imagine the data Fine. So we are going to create or generate or imagine the data. For that purpose, we need the generative AI. But if you want to do classification purpose, we need traditional AI. So in the generative AI, we have both generator as well as our analysis. Both are there in our generative AI. No need to depend on a traditional model for classifier. So both are combinedly we can have in our generative AI. So some of the example of the generative AIs are ChatGPT and DALL-E. So DALL-E is the one of the platform we can use for image creation. So in the DALL-E, we are going to use the basic model of diffusion. Diffusion also is one of the basic model for creating the generative model like transformer. Okay, for creating the video, we have Soras. And if you want to create the code, GitHub Copilot we can use. Fine. Types of generative model in terms of application or in terms of task. If you want to do text to text generation, we can use ChatGPT. ChatGPT is the one of the generative model. Or bring chart. So that also is called as one of the typical model for text to text conversion. So similarly, text to image conversion, we have Stable Fusion, Imagen, and BARD or Mid-Journey. So this and all is called as a text to image generation. Next one is called as an image to text generation. For that, we have the ChatGPT or Lava or Visual Art. Is it clear? Or Flamingo. Okay, these are all image to text generated model. Similarly, image to 3D model, we have Dream Fusion or Magic 3D model. Similarly, image or video to 3D model, we have CSM AI, we have the AI model. Likewise, text to video, text to code, image to science, text to speech to text, or speech to speech. So we have some of the different model. But okay, we have some of the different model. So this different model has some of the core component that has some of the core component. That components are these are. So one of the basic core component of generative AI is called as a transformer. It's called as a transformer. Okay, now I move back here. Okay, so these are the problems we can solve using generative AI. We can use solve using the generative AI. Okay, now we will move on to how to generate the natural images using the generative AI model. Okay, there are many of our model will have the similar structure. Okay, when you are going to generate the model, the similar structures are generation plus inference. Generation means after generating data, we are going to do some classification task, or we may use some of the prediction task. Is it clear? Okay. And so how the generative model is working? For your understanding, I am going to use the generative model. One of the base model is computer architecture. So in the computer computer graphics. In the computer graphics, what will you learn? So you are going to learn some of the different kinds of tasks. We are going to learn some different kind of learning model, or we are going to create some different kinds of learning model like cubic model or cylinder model or rectangle model. Is it clear? So that is the computer graphics going to create. So likewise, okay, in the generative model also, we are going to create the data. So creating the data I'm going to give one of the example through the computer graphics. In the computer graphics, what is the high level descriptor? The cube and cylinder is called as a high level descriptor. That is called as a input. Okay. So from this, we are going to generate. So from the based on the input, whatever we are going to give, based on this, we are going to generate the our raw data. Okay. So here we have written blue and red. So blue, this is the blue one, this is the red one. Okay. And the representation, this is cylinder, this representation is cube. Is it clear? This representation is cube. So based on this, the graphics model will create this one. Okay, the inference means from this graphics model, you can extract the feature. We can extract the feature. So this is the one of the typical generative AI model for computer graphics. Likewise, now we move on to generative model for generation from the raw data for our day-to-day activities. Okay. So here I am going to show some of the statistical models, statistical generative models are learned from data or learn from the data. So here we have to feed the data and prior knowledge. Prior knowledge. These are the two things we have to give us a input to our generative model. Okay. So inputs are images as well as the prior knowledge. Okay. Priors are always necessary, but there is spectrum. There is the spectrum. That is spectrum means some conditions are there. Some conditions are there. Okay. So now, so through this prior knowledge from the existing data, we are going to create the new data. That is called as a Gen AI. That is called as a Gen AI. Now, how that Gen AI the generative model will create the data. For in order to create the data in our generative model, we are going to use some prior knowledge. The prior knowledge is called as a probability function. So through the probability distribution function on our data, or through the distribution function of the probability distribution function of our input data, we are going to develop our generative model. We are going to generate our generative model. So in order to generate our generative model, what we need? Probability distribution of the existing data. Probability distribution of the existing data. Through the probability distribution, you can generate the new data. Okay, we can generate the new data. So this is my input. This is my probability function through which we can create our new data. They are called as a scalar probability. Okay, then next move on to building a simulator for fine. Building the simulator for the generation of the data. So data simulation. Fine. So from the existing data, we are going to generate our new data. That is called as a data simulator, or you may call it as a statistical model, or you may call it as a generative model. This everything is the same meaning. If anybody has saying statistical model for data generation, they are called as a generative model. And how these generative models are represented is a artificial neural network model. It's a typical artificial neural network model. Okay. Data generation in the real world. So this is my image. From this image, so this is the one of the room, I think. One room. So from this room, you want to generate the data. So for that, you have the generative model. This generative model is invented in the 2022 by Menk et al. Menk et al. Okay, from this stroke painting to real images are generated. So okay, and similarly from the text to image conversion, for that also the model is developed. Okay, so that is here. Okay, so what we learn, what is generative AI and what is the function we are going to use on the generative AI to generate the data. Then we learn for what application we can use the generative AI. So these are the applications. Fine. Next, sir, you said generative AI. Sir, how that generative AI are built? The generative, in order to build the generative AI, we have different architecture. One of the architecture is called as a transformer. The second one is called as a generative adversarial neural network. The third one is called as a variational autoencoder. Next one is called as a diffusion model. Next one is called as a auto regressive model or flow based model, hybrid or multi-model. So these are the ways, or using this model we can generate the AI. But I am not going to cover all this. I am going to explain briefly about only one model, transformer model. So what is the typical architecture model for creating the generative AI using transformer? So that's I am going to show. Okay, and before move on to that, okay, what is the core idea of the architecture and what is the best, what purpose it's best, and what is the strength of that each model, and what are the real generative models are there. That's example. That is given in the form of example. Here. Okay, the transformer core idea is self-attention learning concept across sequence. So what it will do, it will try to learn by itself based on the sequence of the data. Okay, so what by this transformer will work best for text or multi-model. What is the strength? Capture the long range of the dependency. So if you have long passage from that, or you want to learn that, okay, for that we need transformer model. So using the transformer model, we have generated some AI, some generative AI, in which one of the example is called, for your understanding, is GPT, Chat GPT, or BERT model, or Clade, or Gemini model. Okay, these are all transformer model. Transformer is the base model for creating this. Similarly, GAN is we can use for generating the video or audio or images, or creating the art. Okay, so for that we can use the GAN model. So right now we have the GAN model. The typical example GAN models are style GAN or big GAN. Okay, style GAN or big GAN. Similarly, variational advisory autoencoder. So that we can use for the purpose for anomaly detection or image synthetics. Similar diffusion model for we can use for generating the videos or audios or images. Is it clear? So what are the existing model that's shown here? Okay, similarly for other models also there, we can go through. Okay, now we move on to what is the typical transformer architecture. So this is the one of the typical transformer architecture model. This is the one of the typical transformer architecture model. It's clear. This transformer model, how will learn, and followed by how will generate the data for our given input, given query. So for that, this is the basic model. So here, this is called as a training model, and this is called as a testing model. Okay, so this testing model also incorporated with our training model, Okay, so how the training is happened, we need the input data, and that input you may have in the form of sequence. We cannot give us a input here. Okay, we have to convert the input in the form of categorical form. For that, we are going to use input embedding and encoding algorithm, positional encoding algorithm. So through which we can convert our longest sequence in the form of number. Okay, on that number as a input, we are going to do multi-head attention model. What is multi-head attention model? Followed by that, we are going to use additional and norm model. Then followed by we add the feed forward model. Then we have the odd norm model. Okay, what is this multi-head attention model? That expansion is given here. Okay, what it will do? This is query image, and this is your key value. Key value means your what you want to generate. Basically, what you want to generate. So the output. Okay, fine. Output data and that value. Is it clear? And then value. So these are the three things we have to give. In the multi-attention model, what it will perform? It will do mathematical multiplication, query and key. Key is the output. Fine. We have to do scaling, and then we have to perform the masking. Then we have to do the softmax, and we are going to do the mathematical multiplication. Okay, mathematical multiplication, and this is called as a multi-head attention model. In multi-head attention model, what is the mat multiplication? So that is this one. Mat multiplication, this is the model. This is the model. Okay, this is the model. Is it clear? So in the multi-head attention model, so this is the one. This is the one. Is it clear? So basically the attention model, this one, there what we are going to do, we are going to perform the dot product. So for your understanding, this is the one of the transformer example. So this is my input image, or input data. So what we want to do, we are going to, using the transformer model, we are going to generate the next token or next keyword. Okay, next keyword. Okay, so this is the input data. Through the input data, first we have to do the learning. For the learning phase is this. Fine. In order to learn the sequence, first we have to extract the token by words. Fine. And these words are converted in the form of number. So that is called as a encoder. That encoder data we have trained. Followed by that, for training, we are going to use decoder, masked self-attention train. Okay, this encoder and decoder combinedly we can have this model. And when you are going to give the test data from the training one, we want to, through the test data, we are going to do the predicting the next word. You can use the predicting the next word of the query, or you want to predict the answer from the given given query. Sorry, for the given query from the training data. So both are is possible. Here, assume I am going to generate the next token for my given input. The cat sat on the, if I am going to give, so I have already trained this on mat. So if I am going to give the test data, we will get the mat output. Okay. So this is called as one of the typical model for transformer. In the transformer, you have only encoder portion. This encoder portion is called as a PERT model. You may heard what is PERT model. PERT model we can use for generating the next keyword. Okay, or next word, or learning the data from the image. So if you have one image, in that you want to extract the data, so we can use extract the value or extract the name, we can use the PERT model. PERT model is the one of the part of the transformer model. The transformer model, we have two fields. One is encoder, another one is decoder. The encoder model, we may call it as a transformer model. Okay, we have the transformer model. Fine. So for that, here I have given one example. Fine. Okay, so this is one of the model. Similarly, we have another model, generative AI is also called as a generative AI also is called as a our in our generative AI, the GPT also is a one of the model. GPT transformer architecture is this the one. GPT, the chart GPT transformer architecture is this is the one. So this I have taken from these places. Okay, so this is the how that labeling or how that training is happened. So that flow is given here. Fine. This and all I will skip. Even we can have LLM also in our GPT. Okay, and chain model also there. Then in our generative AI, one of the model is called as a GAN. So GAN has there are two field. One is generated field, another one is discriminator field. Okay, so how that generative AI model will work here? So that is given here. So what is the generated model has? There are two fields. Generative adversarial learning model has there are two field. There are two main component or there are two main field. One is called as a discriminator, another one is generator. So among these discriminator and generator, who has to run first? The discriminator has to run. What is discriminator? For your understanding, I may say as a classifier. Classifier is called as a discriminator. So previously we have learned the machine learning model has only classifier. So classifier alone, if we have, that is called as a discriminator. Along with that classifier, we have one generator. So that is called as a generator advisory neural network. So there are two models are there, or there are two models are there. There are two components are there in the GAN model. Among which model we are going to use first, or which model we are going to train first. So among which first we will create the classifier model or discriminator model for our real data. So that is the thing we are going to do. Then what we are going to do, we are going to generate our fake data model. Okay, then we are going to train our fake model. So the first model is training this, second model is training this. Then we are generated data also we are going to give along with the real data. We are going to do the classification. When my classification is not correct, then what I have to do when my classification is not correct, when I am going to introduce the generated data, then what we have to do, we have to optimize or we have to update this model. So based on this updation, then you may get the result. If this updation is not, if the updation is not good, then what we have to do? We have to do back propagation. We have to do the back propagation and find the error. Based on the error, we are going to update the weight of the generator and the discriminator, and then we have to go for the testing. So this is also one of the generative adversarial model. The next one is called as a diffusion model. Diffusion model also we can use for the generating the AI model, generating the generative AI model. Okay, so under the diffusion model, we have different architecture. One is diffusion probabilistic model, another one is unit architecture, latent and classifier free model. Basically, we can use this model for the purpose for text to image generation. From image to image generation, we can use this model. Okay, from text to text, we can use transformer, or image to text, we can use the transformer model. Okay, so like this, each generated model, generative model has some application. So based on your application, which generative model you want, that you can use it for your application. Okay, so these are the things I want to cover in my presentation. Okay, so if you may have now question, you may ask the question. I am happy to answer. I am ending my presentation with this. Thank you for the opportunity.
Thank you, sir.
Thank you.
Now it's time for the query session. Dear participants, if you have any queries or anything you want to clarify, you may kindly raise them now.
Participants, if you have any clarification, you can clear it now.
See, sir, the architectures are free. See, they are free model. Even you can get that architecture model, you can get from the ChatGPT itself. First, if you are going to develop any generative model for your application, first take the existing one and then you can adapt for your data. So for the adaptation, we have to apply some of the hyperparameters are there in our training model. Sorry, in our generative model. That you have to update.
Sir, one query
Yes,
from participant from YouTube. How can generated AI different from traditional AI?
sir, in the traditional AI, we can use only for classification or prediction purpose. That means you will give some input. For the input, you need output either for one example I will give. I have email content. In the email content, you may get many advertisement message also, some important message from our boss or from our higher authority. So you want to discriminate these two, you can use our generative AI model. You can use our generative AI model. You can use our traditional AI model. So which are the things are advertisement, which are things are important. Now, what I want to do, along with this message, I am going to generate some fake. See, you may see now there are many advertisement messages are coming. Many advertisement fake images are fake informations are coming in your mail. Is it clear? By mistakenly, if you click anyone, what happened? You may fall onto that block point or fall onto that dead point. Is it clear? Due to that, maybe our money will be go away, or maybe they will use our account for other purpose. Is it clear? So what I am trying to say, in the generative AI, not only we have the classification, along with that we have some fake content also we can generate. We can generate the fake content also. Then whatever we have in the generative model, so the discriminator model as well as generator model. Initially, discriminative model will do only classification on the real data, but now in the generative AI model, the discriminator can do classification of both real data as well as our fake data. So here we need the discriminator model for discriminate or block our fake advertisement. Is it clear? So that is the basic difference between generated model and our traditional AI. Or still, if you want, you may go to this diagram. So this is our traditional one. This part is our traditional one. Just you have to give the data. For the data, you want to get some output. That's all. Is it clear? But generator means along this traditional one, we are going to add one more thing, generator part. That is called as a generative AI.
Okay, sir. Sir, another one question from Dr. Ali Jinnah.
Yes.
How can unsupervised learning be combined with supervised learning to improve accuracy of fraud detection systems.
Yes, sir, listen. See, the basic difference between unsupervised and supervised is, in the unsupervised one, we are going to give input in the form of input as well as output, or we are going to feed the data to the supervised model in the form of input as well as output. Is it clear? But in the unsupervised learning, we are going to give the input only as the data. We are not going to give the label. So basic difference between unsupervised and supervised, yes, or you want to use unsupervised data for the supervised application. So what we have to do, the first step is we have to convert the unsupervised data into supervised using unsupervised algorithm. That is this one. That is this one. Is it clear? See, this is unsupervised data. We have converted in the form of supervised. Using unsupervised algorithm, some of the algorithm is called as a clustering. Here clustering is called as a group. This group, we may take it as a label. This is the output for this label is Tom. This is called as a cherry, or you may call it as 0 and 1. Now we have converted this data in the form of supervised data. Now take this data and apply. You may see here, this output is similar like this supervised model. Now the supervised data, you can use it in our supervised model. You can get our labeled output or our classification output. So before going for supervised one, in the unsupervised one, what we have to do? We have to do the labeling or grouping. The grouping is called as a label. So that labeled data, we have to give it to the supervised model, you will get the output. Is it clear? So that is the one. My point of view, unsupervised data you want to use for the classification. So we have to, along with the supervised model, we have one more extra step is clustering step. That's all. That is the thing. And another one, sorry, in medical image processing, if we are not having sufficient images, data augmentation is best or GAN is best. Sir, data augmentation is older days we are using. What we will use in the data augmentation, we will do any cropping, or we will do any scaling, or we will do any color transmission or transparent. But that and all is not that you can use for creating the volume of the data. But when I am going to use such a thing, then classification accuracy you cannot get best, or you cannot design the best classifier model. Is it clear? You want to create the challenging data, then you have to use the GAN. So like this, you have to use like this challenging one. See, you can see in the sheepdog and map, more or less is showing similar data. Yes or no? Similar one. Like this type of challenging data, if you want to create, and then you are going to use it to your classifier, then you need the GAN model. GAN is the best, my point of view. Is it clear? And also one more thing I want to say, when you are going to work with the medical data, please kindly consult with any of the doctor, then you can proceed. Okay, that is the thing I want to say. Otherwise, whatever you are developing the model, okay, it's waste. We cannot bring it as a product. Okay, we cannot bring it as a product. Okay, so that is the thing. Yes, generative AI is best for market also. So to run the GAN model, if your volume of the data is very small, even you can run it in your CPU machine. CPU machine. Okay. So if you see here, see, I have given one talk in some place. There I have used the generative model for transferring the image from horse to zebra, similarly zebra to horse. See, for this model, see, this is the thing. See, when I use the CPU with number of epoch, I have used 1. I think you know what is by epoch in the machine learning. So epoch is called as a iteration. So we are going to use repeated iteration on the given input to generate our new data. Okay. So here I did only 1 iteration. I got only this. And also I have the images very less. So if we have very less amount of data, then you can use CPU. If you have more amount of data, and then you need the GPU. By default in the Colab itself or the Google itself giving the GPU mission option. So this is the GPU mission option. They are going to use only limited purpose. If you want to use for your research purpose, you have to purchase additional computational unit here. Instead of you are going to buy one GPU machine for you. Is it clear? Here they will give monthly basis or yearly basis. That depends on your requirement. You can use that. What is the use of API? Sorry, API is nothing but the code only. API is nothing but as our Python code. The Python code they have converted in the form of one package is called as a API. Package is called as a API. That package you are going to use it in your application, and then you are going to get the output. Is it clear? See, now there are a lot of methods are there converting the Python code in the form of API. See, convert the Python code to API. For that many apps are there. Sir, many softwares are there. Flask is the one of the thing. Any other question? If no question, I'll stop sharing.
Thank you, sir, for your clarification. Dear participants, share your valuable feedback.
Participants, you can share your feedback with a few words by your what you have got the knowledge by this session. Yes, ma'am. Thank you.
Ma'am, good evening, ma'am.
Good evening, ma'am.
Good
Yes,
evening,
ma'am.
sir.
Good evening.
Good evening, sir.
Good evening, ma'am.
First of all, thank you for your valuable session, sir, about core technology of generative AI. Sir, your presentation with the example really helped us, sir, because it's clearly understand the concept between theory and applications. In your presentation, the scale derivation about the deep learning model in clearly understands, sir, because we know about what level of input supported in each model. And another one thing, your explanation about performance degradation in machine learning and why we move on to the deep learning model is clearly informative, sir. Finally, they explain about what are the problems we have faced in AI and why move on to generative AI is clearly explained, sir. Really such a nice presentation. Thank you, sir. Such a nice presentation, sir.
Hello.
Yes, ma'am.
Hello. Sir, I'm Gomadi.
Yes,
So
ma'am.
thank you for explaining generative AI with such a clear and relevant examples. and it made the concept much easier for understanding me, sir. And also thank you for the Department of Computer Application, Congo Arts and Science College for arranging this kind of FDP, Generative AI Industry 6.0. Thank you, sir.
Thank you, ma'am.
This is Muruganandam from Congo Arts and Science College.
Yes, sir.
I'm happy to part of this Atal FTP. I hope this FTP connects many isolated islands, and you have given a deep knowledge right from the traditional AI and generative AI, and it generates a lot of insights for us. Thanks for the opportunity given. Thank you. Thank you. Thank you.
Thank you, sir.
Thank you all for taking the time to share your feedback with us. Your support means a lot.
Dear participant, a kind reminder, please on your camera for taking a photo. It's a gentle reminder for you. Please on your camera for taking a photo within a second.
Ma'am, the camera is off by your side, ma'am.
Okay, thank you. Thank you all.
Thank you.
Thank you, ma'am. Ma'am, thank you.
Thank you very much, Dr. S. Rajkumar sir, for your insightful and enriching session. The session effectively highlighted a clear and comprehensive overview of the fundamental technologies driving the development of generative AI and large language models. Overall, the session was well structured, informative, and thought provoking. It has motivated the participants to explore further advancement in generative AI and consider their implication for teaching, research, and industry practices. Thank you, sir. Dear participants, important announcement. According to Atal norms, to receive FTP participation certificate, scoring 70% of marks in the final day assessment in the Atal portal, maintaining 80% of attendance and session feedback is mandatory. Once again, I'm repeat, important announcement. Maintaining 80% of attendance and session feedback is mandatory. Scoring 70% of mark in the final day assessment in Dear participants, important announcement. According to Atal norms, to receive FTP participation certificate, maintaining 80% of attendance and session feedback is mandatory. Scoring 70% of marks in the final day assessment in the Atal portal.
Okay,
Thank
ma'am.
you
Thank
all.
you.
Okay, ma'am.
Thank you all. Good night. Have a nice sleep.
Good night, ma'am.
Feedback
Thank
is
you, ma'am.
shared. Put the feedback, participants. Thank you for all of you.